This is the Precal review for 8.5, 8.6 test that's due Friday. Instead of sending you the key, I'm going to send you this video, and I'm going to work through all of the problems and show you how to work them, so you'll know how to show the work and that kind of stuff. Okay, so on number 1 on the review, you have two different vectors. You have vector DJ and vector AB, and then A is at -3, 3, and B is at 3, 4, and then D is at -1, 1, and J is at 3, 2. So those are the coordinates that they give you. So you have to choose the graph first. Well, when we think about A is going to be, so if this is A and this is B, A is -3, 3, and then you're going to 3, 4. So AB is going to go in this direction. Then for DJ, D is -1, 1, so that's down. That's left 1, down 1 right here, and then it's going up to 3, 2, like this. Okay, so they don't even look like they have the same direction. Okay, but that's what the graph looks like. Okay, so that's what you got to graph, and then you're asked if they are equivalent vectors. So you've got to find the distance, and you've got to use distance formula when you've got 2 points like this. So you've got to use distance formula on both of them. So let's do DJ first. Distance formula, x2 minus x1 all squared plus y2 minus y1 all squared. And then, so DJ, so square root of, let's see, 3 minus -1 all squared plus 2 minus -1 all squared. So that's 4 squared plus 3 squared. That'd be 16 and 9. So the square root of 25, which is 5. So that's DJ's magnitude. That's the magnitude for DJ. And then for AB, we've already got the distance formula written, so we could do 3 minus -3 all squared. That's 2 negatives there. 3 minus -3 all squared plus 4 minus 3 all squared. So that's a 6 squared and a 1 squared, which would give me square root of 37. So they're not equivalent because one's got 5 for the magnitude. This has got the square root of 37 for a magnitude. So these are not equivalent. They're not going the same direction, and they're not equivalent because they don't have the same magnitude. Okay, so that's number 1. Then on number 2, you've got to take the Q equals 3I plus 4J, which is in linear notation. That's in linear notation. And you want to find the direction angle. So the direction angle is where you do the inverse tangent of, we'd say y over x. It's the second one over the first one, or j over I. You can even put j over I, but it's the second one over the first one. So you do inverse tangent of 4 over 3. Okay, so inverse tangent of 4 over 3, and then, excuse me, type that in your calculator, inverse tangent of 4 over 3, and you get about 53. Now here's where you need to be careful, because a lot of y'all missed this on one of the tests. You've got to make sure that is in, on the last test, on test for 8.3. You've got to make sure you're in the right quadrant. Is this in the first quadrant? How do you know? Because they're both positive. So since they're both positive, it is in the first quadrant. This is a first quadrant angle. Remember your quadrants. This is 0, 90, 180, 270. So it would have to be, it's in the first quadrant because these two are positive. Because this could be a reference angle. If this was like -3, 4, we'd be in the second quadrant. So we'd have to be doing something with 53 to get a second quadrant angle. So make sure you get it in the correct quadrant. Don't just do the inverse tangent and stop there. Make sure you're in the right quadrant. This is in the first quadrant because they're both positive, so we're good. So if the first one's negative, second one's positive, you're in second quadrant. If they're both negative, you're in third quadrant. If the first one's positive and the second one negative, you're in fourth quadrant. And then, of course, if they're both positive, you're in the first quadrant. So make sure that you are very careful with that and pay attention to that, okay? Then on number 3, This is one like you had on the homework, on the notes and on the homework. And I'm not going to draw the picture because when you've got the review in front of you, you can see it. But we need to find F. And if you look at F, it's in a triangle. I will draw the triangle that F is in. This is 83 degrees, this is 650, and this is 100. Now, there's a real complicated way to use vectors on this, but we need to find F. Here's F. Guys, we can use law of cosines. It's an easier way to do it. That's what I showed you on the notes for the homework and stuff. So F is going to be the square root of 650 squared plus 100 squared minus 2 times 650 times 100 cosine 83. And when you type that in your calculator, you get something around 645.49. Okay, that's F. That's the first thing you're asked for is F. So that's F. I think you're asked to round it to the nearest integer, so it'd be 645. Okay, so this is 645. Now, what we have to find is the new direction of the boat, right? Yes. It started at 39 degrees, but then this wind came and it's pushed it. It's pushed it this far, okay? So now it's on this heading. We found the magnitude of that heading, that's F. Now we need to find the whole angle it is now from north, okay? From due north, we need to find this whole angle. We know part of it is 39 because that's where it started. Then the wind's pushed it, so we need to find this angle. Again, there's a complicated way to use vectors I'm not going to show you. We can use law of sines. I can set up a proportion with law of sines, okay? So we could put sine of theta over the side opposite it, which is 100, equals sine of 83 over 645. Way easier to do it this way. So the sine of theta, you move the 100 over, so 100 sine 83 over 645, and then you've got to do the inverse sine. So when you do the inverse sine of 100 sine 83 over 645, you get something like 8.85, which is about 9. So when we put 9 here for theta, because that's what theta is, and that's not the whole angle of the boat because we want it from due north. So we know it was going 39, okay? Now it's pushed 9 degrees from that, so we'd add 39 and 9, so now it's at a 48 degree angle. That's its new direction. That's its new angle of direction. And this is its magnitude, its new magnitude, okay? Because of the wind. So that's number 3. I think that's the most complicated one you have on the whole review. Everything else is real simple. Then on number 4, you've got the drawing there. It's got a 100-pound rest on a 25-degree incline. Find the magnitude of the components of the block's weight, perpendicular and parallel. If you want perpendicular, that's cosine. If you want parallel, that's sine. And it's just magnitude times the cosine of the angle. That's perpendicular. Parallel is magnitude times the sine of the angle. Okay? So we've got to find perpendicular first. So my magnitude is 100 pounds. Cosine 25. That gives me about 90.6 because you have to round it to the nearest tenth. And then parallel would be 100 sine 25, which is about 42.3. And that's all you do. That's all you do. These would be in pounds, but actually on the review it's labeled. So there's that one, number 4. Then for number 5, you've got this vector that should be pointed brackets, negative square root of 3 over 4, and then 1/4. And you want to find the magnitude and the direction angle. Okay, so magnitude and the direction angle. So magnitude, your magnitude is always the square root of x squared plus y squared. It's also your r. Remember, this is also r. Like when we're talking about sine is x over r, sine is y over r, cosine is x over r, tangent is y over x. This is also finding your r. So this is your x and this is your y, okay? This is actually your cosine and your sine for this angle, okay? But we want the magnitude. So we plug in negative square root of 3 over 4 squared plus 1/4 squared. So that would give me 3 over 16, because the negative square root of 3 squared is 3, 4 squared is 16, plus 1 over 16, which would give me 4 over 16. That reduces to 1/4, and then I do the last thing, I square root it. So don't forget to square root it. So there's your magnitude for this. Again, your magnitude should always be positive because it's distance. Now we've got to find our angle of direction, okay? So that's the magnitude. Now we need to find the angle of direction. And this is where we have to be real careful. So the angle of direction is where we start with that inverse tangent. We do the inverse tangent of y over x. So we've got to do the inverse tangent of 1/4 over square root of 3 over 4. Do not put the negative in here. You don't need to, okay? You don't need it. Now let me show you how this would look on your calculator. Let me clear everything off. Let me show you how this would look on your calculator. So you're going to do second tangent. Wow, it's not focusing in on it for some reason. Okay, that's good. And then you're going to start another set of parentheses, and you're going to put 1 divided by 4 in the numerator, divided by, you're going to put your square root. Actually, you're going to start second tangent, open parentheses, 1 divided by 4, close parentheses, divided by open parentheses, square root that 3, get out from underneath that radical, divided by 4, close parentheses. Okay, so this is 30 degrees. Guys, that is not your angle of direction because it's a negative, then a positive. The first one's negative, the second one's positive. So 30 is not the angle of direction because you're in the second quadrant. You're here. 30 degrees is over here. We need to be between 90 and 180. So if my reference angle is 30, I would do 180 minus 30 to get the correct angle. So this is my angle of direction, 150. Why? Because I'm in the second quadrant. Why am I in the second quadrant? Because it's left square root of 3 over 4 and up 1/4. Left square root of 3 over 4, up 1/4. So my direction angle is 150. My magnitude is 1/2. You've got to be careful with these angles. You've got to be careful with these angles because y'all were not on the last test. And that's why a lot of you, when I sent back, I said, you know, you got to be in quadrant 2, you got to be in quadrant 3, you got to be in quadrant 4, because y'all weren't doing that. Okay, then on number 6, you've got this where this is theta right here and this is V, and this is 9 and this is 14. So you're wanting the speed, which is your magnitude. Speed is the same as magnitude. I'm just going to put mag. So it's the square root of 14 squared plus 9 squared, which is about 17. You get about 16.64 and you have to round it to the nearest whole number. So there's your magnitude. Then we want the angle with the horizontal. So the angle with the horizontal. So we want this angle, and they even show it to you. So it's the inverse tangent of 14 over 9. Inverse tangent of 14 over 9. Guys, this is a first degree. This is a first quadrant angle. How do you know? Because they're both positive. 9 and 14. Your triangle's shaped like that. So you just do the inverse tangent. They're asking you for the angle with the horizontal. So you just do your inverse tangent, second tangent of 14 over 9, and you get about 57. And round it to whatever you're asked to round it to. Make sure you round them correctly, because if you don't round them correctly on this review and test, I'm going to mark them wrong. Why? Because I'm doing them all for you. I'm doing all of the review for you. So you need to make sure that you do your answers correctly, okay? Then let's see, number 7, that was number 6. Number 7 wants you to take the component form, negative 8, 4, and write it as a linear combination. So negative 8i plus 4j, you're done. That's number 7. Number 8, okay, let me put number 8 up here because I need to draw a picture. Okay, so number 8, we have an airplane is flying at 250 kilometers per hour in a direction of 290. Find the westerly and northerly components of its velocity. So here's where you have to be careful when you're talking about this. Remember, this is north, south, east, west. So our angles change. This is 0, 90, 180, 270. Okay? Now, we're told that flying at 250 kilometers per hour, that's a magnitude, and then we're at an angle of direction of 290. So it's right here, okay? That's how the plane is flying right now. And this, your R, is 250, not 250 degrees. 250, that's the speed. So we need this angle right here. So if this is 290 and that's 270, if the whole thing is 290 and this is 270, that means this angle is 20. And we want the westerly and northerly. So we want X and we want Y. We want horizontal and we want vertical, okay? So it's like horizontal X is your magnitude times the cosine of the angle. And then your vertical Y is the magnitude and the sine of the angle. So we just plug in what we've got. Our magnitude is our speed, so 250 cosine 20 and 250 sine 20. 250 cosine 20 this is your west, okay? It's your horizontal, it's your west, and it's 234.9, about that. And then your northerly one, which is your sine, is about 85.5. Okay, so that's your northerly and westerly components, or your vertical and your horizontal components. Vertical north, horizontal west. Okay, sine and cosine. That's the way those work. That was number 8. Now for number 9, you have two vectors and they make a 90-degree angle. You're given two vectors. You're given vector u, which is 48. So I'll put u here. This is vector u. This is vector v, which is 31. And then it's at a 90-degree angle there. And we want the magnitude of the resultant vector. So it's like I want r. So magnitude, square root of 48 squared plus 31 squared. Square root of 48 squared plus 31 squared is about 57.1, rounded to the nearest tenth. Then you want to find the angle the resultant makes with u. With u. So we want this one because we want the resultant made with u. We want the angle it makes with u. So it's still an inverse tangent, but you've got to make sure you put 31 over 48 because it's opposite over adjacent. And we want the angle it makes with u, which is this angle up here. If we wanted the angle with v, it would be this angle down here, and it'd be inverse tangent of 48 over 31. Which gives you about 33, rounded to the nearest degree. And again, we don't have to worry about which quadrant it's in or anything like that. We just find that angle that it makes with u. Okay, then on number 10, we want to find the unit vector that has the same direction as the given vector. So my vector is 3, 4. So what you have to find first is your magnitude, or r, okay? Magnitude and r are the same thing. So square root of 3 squared plus 4 squared. Hopefully some of you recognize that this is a 3, 4, 5 pi trig, because again, we're talking about right triangles. We're always talking about right triangles. So this is like an A and a B, and you need your C. So r is 5. And then what we want is, it's like you want a cosine and a sine. We want to put x over r, and we want to put y over r. So x is 3, so 3 over 5. And then y is 4, so 4 over 5. So there is, it's a vector with the same direction. It's also a parallel vector. It's also your cosine and sine. If you were to write it in cosine and sine notation, this would be your cosine, this would be your sine. It's all the same thing, okay? Then you've got some operations with vectors. So for example, on number 11, u is 5i plus j. So these are in linear combination form, and w is I minus 7j. And we want to do 3u minus 6w. So 3 times 5i plus j minus 6 times I minus 7j. So I distribute 15i plus 3j minus 6i plus 42j, and I combine like terms. 9i plus 45j. And then they want it in component form, 9, 45. So they'll want it in linear. There's like 4 different answers there because they want it in linear combination form, and then they want it in component form. So make sure you fill both of those out on that. So that's number 11. Then number 12. Okay, so let's see on number 12. We've got theta is 11 pi over 6. So we want to graph that first. I always change them into degree because for me it works quicker. So my pi's cancel, 6 goes into 180, leaves a 30. So this is a 330 degree angle. So if you have to sketch it first, that means you are in the 4th quadrant, okay? And you do have to sketch it first. You're asked to sketch it first, so make sure that you look for it in the 4th quadrant. And then we want the unit vector with the given direction. So we want the sine and cosine. We want it in ij. Well, this will be the cosine and this will be the sine, okay? So we put the cosine and sine in front of it. So if this is 330, this reference angle that we have to use is 30. Now remember, if I'm in the 4th quadrant, cosine is positive because I went right and sine is negative. So when I put them in, I've got to make sure I put the right signs on it, okay? Now since my reference angle is a 30 degree angle, the cosine of 30 is square root of 3 over 2, and my sine of 30 is 1/2. Square root of 3 over 2 and 1/2. So cosine goes first, so square root of 3 over 2. In the 4th quadrant, I just said cosine is positive, so I leave it square root of 3 over 2, so that's what you put in front of the I. Then my sine in the 4th quadrant, it's 1/2, but it's negative because sine is negative in the 4th quadrant. So you've got that right there. You put the cosine and sine in, you use a reference angle, like 30, because this is 330. This right here would be 360, so that's my reference angle is 30. Cosine of 30 square root of 3 over 2. Sine of 30 is 1/2, and then I change the signs. Cosine in 4th quadrant is positive. Sine in 4th quadrant is negative. So those are the two numbers I put in for that. That's number 12. Then number 13, we have two forces, 31 newtons and 53 newtons, act on an object at right angles. So right angles, 31 newtons, 53 newtons. Find the magnitude. So that's the square root of 53 squared plus 31 squared, which gives about 61 newtons. And then we want the angle that the resultant makes with the smaller force. My smaller force is 31, so I want that angle right there. If I wanted it with the larger force, I'd put theta up there. Still an inverse tangent of opposite 53 over adjacent 31, because I want the angle it makes with the smaller force. So then that gives you about 60 degrees when you round it. Let me check that one right quick. Inverse tangent of 53 divided by 31. Yeah, it's about 60. Okay, so that was 13. Now for number 14, we want to calculate 3v plus o. That big O there is just the 0 vector. So it's really, we're just doing 3v. We're given that v is negative 6, 8. So I do 3 times negative 6, 8. So that'd be negative 18, positive 24. There you go. And I add 0 to it so it doesn't change it. So that's your new component form of that vector. Then number 15. Number 15, let's see. This is drawn for you. This is 87 and this is 31 degrees. And we want the horizontal and vertical components. So your horizontal component, that's your x. That's why I always put an x by it. Remember, that is your magnitude times the cosine of the angle. So you would do magnitude 87 times the cosine of 31, which gives you about 74.57 pounds, because it asks what to label it in, and it's pounds. Then your vertical, or your y, is the magnitude times the sine of the angle. So that'd be 87 sine 31, which is about 44.81 pounds. So that's how that works on 15. That's your horizontal and vertical components. 16 is the same way. It's just asked a different way. We've got an airplane, takes off at a speed of 240 at an angle of 19 with the horizontal. Resolve the vector S into its components. So again, You want the horizontal, you want the vertical component. So my horizontal component would be the speed, which is 240, times the cosine of the angle 19. And then my vertical component would be 240 sine of 19. So then 240 cosine of 19 is about 227 because they want it to the nearest whole. And then 78 for my vertical. Vertical, horizontal, that's the way those work. Then 17, when you see those absolute value brackets, that means you want the magnitude after you've done this, okay? So they show that W is -1, -2, and we're going to subtract V from it, which is -5.7. So we're going to do that first, and then we're going to find the magnitude. So -2, -4, plus 5 minus 7, because I need to move that subtraction sign through like a distributive. Now I combine -2 and 5 and get 3, and -4 and -7 and get -11. So there's my new component form. And then we want the magnitude of that, which would be the square root of 3 squared plus 11 squared, which would be the square root of 130, which doesn't simplify any. If your radicals simplify, you need to simplify them, but this doesn't because it's just 2 times 5 times 13. There's no doubles there, so you leave it as a square root of 130. Now again, if I went over that too fast, then rewind it. Watch it again and see what I did, okay? That's a nice thing about having the video is that you can rewind it and watch it again to see what I did if I went too fast. Number 18, we are calculating 6u minus 2v. So 6u, u is 5 comma -2. We're subtracting 2v, which is -5.6. And all we're doing is just that. So this is 30 and -12. And that'd be a plus 10, -12. I'd be combining. So that's going to be 40 and -24 in component form. They want you to leave it in component form, or I want you to leave it in component form. So there you go. Okay, then on number 19, we've got a wind that has an easterly component of 11 and a southerly component. So easterly component, southerly component. Easterly component is 11, southerly component is 18. So when I think about this, this is north, this is east, this is south, this is west. Okay, that's an N, not a W. Okay, so I got to remember that. This is 9, this is 0, this is 90, this is 180, this is 270. Okay, because I'm going to be asked for prop magnitude, and I'm going to be asked for the angle of direction, which would be this whole angle. This part's 90 degrees, but I've got to find this piece because I want the correct direction of the wind, which is blowing this way, not up in the first quadrant, okay? Not up in this quadrant right here. We're in this quadrant between 90 and 180. So I need to make sure my angle of direction is between 90 and 180. So the first thing I want is the magnitude. Magnitude of the wind, that's the square root of 11 squared plus 18 squared, which gives about 21.1, because you're supposed to round it to the nearest tenth. Then the direction of the wind, so I do an inverse tangent of 18 over 11. Okay, because I'm finding that angle right there of 18 over 11. Inverse tangent, opposite over adjacent. So let me check this one. Inverse tangent of 18 over 11. And I get about 59. It's like 58.57. I'm going to round it to 59. Okay, so this angle is 59. That is not my angle of direction, because I want to go from due north. So I've got to add the 90 degrees to the 59. So 90 plus 59 gives me 149. So there's the correct angle. This is the magnitude, and this is the correct angle of direction on number 19. Okay, then number 20. Number 20, let's see. We've got m is 3 comma -8, and n is -8 comma -2. This is vector mn. Sometimes you see it with just one half of the arrow. This is vector mn. We want the component form of the vector. To find the component form of the vector, you take the second point, the terminal point, and subtract the first point from it. So -8 minus 3 is -11. and then negative 2 minus negative 8 would be 6. So the component form is negative 11, 6. And then we want the magnitude of that component form, square root of 11 squared plus 6 squared, which would be 121 and 36, which would be the square root of 157, which doesn't reduce any. And it says, simplify the answer including radicals. So don't put a decimal on this. Just leave it as a square root of 157. Same on the test. Okay, then on 21, you've got u is 4 comma negative 2, and you've got v is negative 2 comma 4, and you're wanting to find u times v, which is what we call the dot product. To find the dot product, it's x1 times x2 plus y1 times y2. That's how you find the dot product. So we would do 4 times negative 2 plus negative 2 times 4. That would be negative 8 plus negative 8, which is negative 16. That is called the dot product. Okay? That's what that's called, is the dot product. And that's number 21. And number 22. 22, a block of ice weighing 60 pounds rests on a 32-degree incline. What force parallel? Okay, so guys, this one is like number 4. We want the parallel force. The parallel force is your sine. So we're going to take the magnitude, which is 60, times the sine of 32, which gives about 31.8 pounds. Okay. Then number 23, a baseball player throws a baseball at a speed of 79, angle of 45 with the horizontal. Resolve the vector, so you want the horizontal and vertical components. Horizontal is your magnitude, which would be the speed, times the cosine of the angle, and then your vertical is magnitude times the sine of the angle. Now, because this is a 45-degree angle, these are going to be the same, 55.86, because the sine and cosine of 45 are the same. And it's miles per hour. Both of them are miles per hour. That's number 23. That's the horizontal and vertical components. Then number 24, you've got negative 3i plus 2j, and we want the cosine theta I plus sine theta j. So we want to find the cosine and the sine. Remember, cosine is x over r, sine is y over r. So I've got x and y right here, but I need r. So you need to find the magnitude, which we've done this before. They just ask it in a different way, like which vector has the same direction or which vector is parallel to it. This is another way to ask it, okay? So I've got to find r, the magnitude, which is the square root of 3 squared plus 2 squared, which would be the square root of 13. Then my cosine, I take x, which is negative 3 over r. And then my y is 2 over the square root of 13. And you can't leave it this way. So it'd be negative 13 squared, negative 3 square roots of 13 over 13. And then 2 square roots of 13 over 13. And that's all you do. They have the I there already for you, and then they have the J there already for you. So it looks like that. But they already have the I and the J. So these are the two things you put in the blanks. That's your sine, that's your cosine, and that's your sine. Because cosine is x over r, sine is y over r. That was number 23. No, that was number 24. Sorry, that was number 24. Last one, number 25. 25 is the last one. So on 25, we're going to calculate v plus u plus 2w. Well, v is negative 4, 8. U is 5 comma negative 2. And w, so 2 times negative 2, negative 4. So this last one would be negative 4, negative 8 that I'd be combining. So I'd combine all my x's. Negative 4, 5, negative 4 would give negative 3. And then I'd combine 8, negative 2, and negative 8, which would leave a negative 2 in component form. That's the review. Again, it is due 5/1 Friday. It's due with the test. These are the only 2 assignments you have this week. You have this review due Friday, the 1st. Well, you've got, this is the review. It's due May 1st, Friday, and then the test is also due May 1st. And then you don't have another lesson on the computer this week just the review and test, just this review for 8.5, 8.6, and then the test 8.5, 8.6. And I hope this video helps. Show your work, that kind of stuff. There you go.